Hello everyone. I hope that all of us are doing well, and let us start with today's session. So, of course, it is going to be very interesting, right? So, let us start with the session for today, right? And so, the topic that we have covered yesterday, we have to move forward, and we have to see that what all things can be covered today. So, let's start with the operators. So again, let us start and resume the session and let us see that how much can be covered in this coming hour, right? So let's start with it. So the first thing is, now you may think that why am I not installing the software? Because obviously I'll have one session wherein I'll be explaining you that what software we are going to use. But before that, I want that every one of us should be very comfortable in coding. So that's why I'll do that part in a little bit, right? Maybe after one or two lectures. But for now, let us start with the operators in Python. So first thing is first, and that is that I'm going to open Python compiler. So here, what we are going to do is we are going to start with the operators. Yesterday we have covered conditional operators, right? So whenever we want to make an statement, right? Suppose we want to compare or we want to compare two numbers or two strings or any two objects, right? So at that moment we use these comparison operators. Other than this comparison operators, we have several other operators as well, such as arithmetic operators. So this is the second class of operators that we have to study, which is arithmetic operator. So arithmetic operators will contain all of your mathematical operators, right? So in this, you will have plus, you'll have minus, you'll have division, right? Then multiplication is there, then your mod division is there, right? Then exponentiation is there, and yeah, one floor operator is also there. So this is the complete category for arithmetic operators, and let us go on each of these operators one by one, and obviously you're going to enjoy this session a lot today. So let's start with that. So starting from the mathematical operators, the first operator that we have to cover is plus operator. So suppose we have this particular number one variable in which we are storing 40, and then we also have this second number which is number 2, and this number 2 will contain 50. And what do we want to do on these two variables? So we want to add up the values. Now, one thing should be very clear before going for arithmetic operators, which is your equal to operator. So, equal to is also called as assignment operator. And the work of this particular operator is that it takes the right hand side, it evaluates the right hand side, and then after evaluation, it puts the value of the right hand side to the left hand side. So, the right hand side could be a single constant value like 40 and 50. It could be an expression, it could be a function call, right? It could be anything, right? So first of all, the right hand side of equal to operator is solved, and after the solution, that right hand part will be given back to the left hand part, and then that left hand variable will contain that answer, right? So this is how this particular operator, equal to operator, works. So how does this equal to operator works? So the left hand side, right, or the right hand side is evaluated first. The right hand side expression is evaluated first, and then the value after evaluation, a single value comes which is given to the left hand side of the equal to. So it can be any variables which the value will be assigned to, right? Now suppose we have another variable which is called as result, And inside this result variable, we are going to keep the sum of number 1 and number 2. So plus operator is a binary operator which basically calculates the sum, and then you can store it inside the result variable and then you can print it out. So let us print the value, which is print sum is equals to, and what is it equals to? So the value of result. So here what we are printing is a message first of all. This message is just a simple text, and afterwards we are printing the result which contain the addition of number 1 and number 2. So this is a simple plus operator. As soon as we will run it, we will get the output as 90, which is the addition for 40 and 50. Afterwards, you can also go for some other values. For example, if you want to do the difference of these two numbers, then you may call the variable as difference, and you have to simply go for num1 minus num2. And here, if you will print the difference of these two numbers, then you will get some result of this sort, wherein you're saying that difference is equals to, and the value that is kept inside diff variable. So this is what we are doing here. Then in the similar way, you can go for multiplication and division as well. So suppose we are saying that multiplication is another variable in which we are going to keep. So it is not required that always you have to take the variables num1 and num2. If you want, you can take some constant values as well, like 5 into 6. And then these two numbers will also be calculated for multiplication. So the answer 30 is going to be stored inside mul. That is the variable, right? And then we can print this out saying multiplication multiplication is equals to, and then the result of this multiplication which is in this variable. And similarly the division operator works, which will basically do the division. So suppose we are saying that num1 divided by num2, and whatever division is there we will keep inside div variable. So now again we are coming up with a text which is going to say that division is equal to, and then we will print the value of this div variable. Now let us run it. So we have worked on the four operators which are plus, minus, division and multiplication, right? So these were the very basics of all the operators that we are going to cover afterwards. I think that up until this point we are very much clear with the whatever we have covered, isn't it? Guys, are we clear up until this point? Kindly respond in the message section. Are we clear up until this point? Alright, so this is clear, I guess. For everyone it is clear, right? Now the next operators which comes into picture would be, so let us start with this next operator, which is basically your floor division operator. So suppose if we will divide these two values, suppose I am saying that the first value is 4, or otherwise the first value is 34 and the second value is 3. Now if we will divide these two values, what will happen? So let us see the result, right? So I'm saying that divide these two values, which is num1 divided by num2, and let us run this. So you are getting the result as 11.3334, right? This is the result that you're getting. Now we want that, okay, this fractional part should not come, right? we want that the fractional part should not be, this is a day 2 class, right? The fractional part should not be there. So the other division operator that you can use at this point is floor division. What does this floor division do? So this floor division basically removes the fractional part. So in this case, what you can expect as the output is 11. This fractional part will be completely removed, right? Let us run it again. So this time the output that you're getting is 11. So I hope that this is clear, right? This is how floor division works. This is the second operator, which is floor division. And what does this floor division do? So this basically removes the fractional part, if any, right? Now the next operator that is there is exponentiation operator, or before that let us go for mod operator. So mod operator basically gives you the remainder after floor division. So suppose you're dividing two numbers. Let us consider that we have 13, and we are dividing 13 by 3. Now you all know that 3 into 4 is 12, right? So 1 is remainder in this case. So you don't have to go for the fractional part, and whatever remainder is left, that you have to print whenever you are using this mod operator. So mod gives the remainder, right? So now let us run it again, and this time you're getting the answer as 1. It simply means that the remainder is what you're getting here. Now instead of 13, if I'm going to write 14, so obviously the remainder will be 2. So let us run it again, and this time the remainder is 2. So this is how it works, right? This is your mod operator, right? Let us write it over here. So this is our second operator, which is modulus operator. Afterwards, after modulus operator, the next operator that comes into picture is your exponentiation operator. So suppose num1 is containing 3 and num2 is containing 4, and we are writing that num1 exponentiation num2. So this is basically something like this. What you're writing here is equivalent to this particular thing, which is 3 exponentiation 4, 3 raised to the power 4, which is equals to 3 into 3 into 3 into 3, right? Which is 81. So now if I'll print it here, obviously we are going to get the output as 81. So this is what exponentiation operator is. So we have covered three more operators at this moment, that are modulus operator, then exponentiation operator, and then floor division operator. Is it clear? Is it clear, everyone, how it is working? All these three operators, modulus operator, then we have exponentiation operator, then we have floor division operator. So are we all clear with this one? It's clear. All right. Now the next thing is, after arithmetic operator, we have another category of operators that are your next operator, that are logical operators, because we have already covered the comparison operator yesterday. So now we have to come up with the next category of operators, that are logical operators, right? In the logical operators, we have AND operator, we have, so here we have to write AND in for the input that they can be provided with. So hence there are only four possibilities of the expressions that can be made out. For example, either you will say that the first input is false, and the second input to this AND operator is true, right? This could be one set of the inputs that can be given to this AND operator. Other set of the inputs could be that the first operand is also false and the second operand is also false, right? Other set of the input could be that both of the operator are true, so true and true, right? This could be another set. Then the last set for the operator could be true and false, right? So these are the four possibilities that you can give as input to the AND operator. So true and false. Now let us print the output. So obviously AND works as if multiplication of 0 and 1 is working. So if you want to remember this, what you can do is you can assume that false is equals to 0, right? And true is equals to 1. And if you will multiply these zeros and ones with each other, what are the outputs that you're getting? So 0 into 0, that is multiplication you have to use. So 0 into 0 is obviously 0. It means the final result of this particular expression, false and false, would be false itself. Then the second expression is false and true. So false is basically 0 and true is 1. So 0 into 1 is again 0. So the final output again you're getting is false. Then the next expression is true and true, and both true and true are 1 into 1, which is equals to 1. So that's why the final output that you're getting here is true. And the last one is true and false. So 1 into 0, that is 0 again. So you're going to get the final in output as false. So this is how AND operator works, right? If you want, then you can get it printed also. So let us do that as well. Let us check the output directly onto the console. So these are the four print statements that we are having. And in these four statements, we will print the value of each of the expression. The first expression is true and true. Let us see what is the value for this particular expression. Then the second one would be print false and false, right? Let us see what is the final output for this particular expression as well. And then two more print statements are there. So in the first print statement, we are going to have this expression. So we are putting this one here. And in the second one, we are going to put this expression, right? So we just want to check out that the values that we have calculated are the same. So let us run it again. And yes, it is absolutely same, because for the first expression we are getting true and true as true, and for rest of the operator where even one false is there, you're going to get the false as your final result. So this is how logical AND works. So I hope that this is completely fine with you all guys. Now a question may come that why do we need it, right? That why do we need true and false and false? What is this actually? So we'll see it in examples also, in running example. But before that, let us go for OR operator as well. And even before that, you have to tell me whether it is clear to you people or not. Is it clear, everyone? Logical AND operator, is it clear? So we are going to learn a lot of concepts from different fields. For example, we're going to do a lot of projects as well from data analytics field, right? So you have to be very attentive in the class, and whatever doubts you people are having, you can ask in the chat box there itself. Later on, we will cover Power BI and Excel and other analytical tools, right? Probability and statistics. A lot of things are coming up, but the only requirement for these classes are that you should be regular. Can I expect that you people are going to be regular in these classes, guys? Do I have to remind you every day to join these classes, or should I expect that from today onwards I'm going to expect you people in each of the upcoming session? Yeah, Power BI is going to be there, but we have to go in a certain order, of course, right? So we have to start with Python, then we have to go for certain mathematical libraries, then we have to follow a certain order. So, but later on, yes, of course, Power BI is going to be there, and Excel and different tools and things are going to be there. And if, of course, the response will be good, then we will go for data science as well. So, some sort of machine algorithm or AI technology will cover. But that is something that that is basically in the later on section. First of all, let us complete our data analytical part, right? So that let us learn something good and new and easy first, and then we will jump on to the AI part, right? Why Power BI start class? I don't know what you are asking, Bhanu. Why Power BI start class, please? I think you're asking then when these classes will start. So basically after Python, first of all we have to cover statistics, SQL, right, and other libraries, and then only we'll jump on to after Excel we will go for Power BI. So we have to follow the sequence, right? You people just have to join every day at 9 o'clock, right? All right. So this is about and operator, and afterwards we have another operator as well, which is or operator, again a logical operator. So how does this or operator works? Obviously it also again has these four combinations that are possible, which are print. Let us see the direct result. And basically what happens in this case is that you have two options for the operands, of course. So the first option is that you are giving false or false, right? False or false, and the output would be false, of course, because or operator says that if both of the operands are false, right, both of the inputs are false, then you're going to get the result as false, and if even one operand is true, then the final result will be true. So let us see. Basically you have the playlist of Python where you can get the first day lecture as well. It was taken yesterday itself, so you can get it very easily. Just surf through the YouTube channel, you'll get it. Right, false or false, and afterwards the second combination could be false or true, right? And then the other option is true or true, and the last option is true or false, right? So this is the fourth combination that is possible if you have only two possible inputs that are true and false. So here we have true as first input and false as the second input, and the answer that we are getting here is false, true, true, true. So this is something that we are getting at this particular point, and I hope that this is clear, everyone. This is your logical OR operator, right? Afterwards comes your next operator, which is NOT operator. NOT simply do this thing that it converts false into true and true into false. So this is how NOT operator works. Let us see. So if you will say that print what is the value of not true, then obviously you are going to get the answer as it basically reciprocates the result. So not true simply means false, and if you will take the just opposite, that is not false, then you are going to get the answer as true. So it reciprocates your result, and let us see. So false and true, this is what you're getting in this particular case. So I hope that this is also very fine, right? This is a not operator. Now the next series of operators that we have is very interesting, and it is bitwise operator. So whenever you try to start working on the bit level rather than working on the number itself, then your bitwise operators come into picture. So now what happens is that, okay, I'll give you a very fast introduction and theory of this particular class, of this particular operator, and you people are going to enjoy it, of course, a lot. So basically what happens is that if you want to represent 0, right? So 0 is represented as, if suppose in 32 bits we want to represent it, then there are 32 bits and the last 4 bits are looking something like this. If we talk about 1, that how 1 is represented, then it is 0, 0, 0 and then 1. If we talk about 2, then it looks like 0, 0, 1, 0. If we talk about 3, then it looks like 0, 0, 1, 1. If we talk about 4, then it looks like zeros, 1, 0, 0. Now you people will think that how do I remember all this? So there is a technique which we will discuss in the later sections. But right now just assume that okay, this is how they look at the bit level, right? Then if we talk about 5, then it looks like 1, 0, 1, right? If we talk about 6, then it looks like in the memory, it looks like 0, 1, 1, 0. If we talk about 7, then it is 0, 1, 1, 1. Then 8 looks like, then 8 is looking, 8 looks like this, that is 1, 0, 0, 0. Then 9 is 1, 0, 0, 1. Then 10 is 1 1, sorry, 1 0 1 0, and so on, right? This is enough. Now what we want is that we want to do logical and not logical, bitwise and operator we want to use over these numbers, right? So there are several bitwise operators such as AND is there, then this is OR operator, this is XOR operator, right? And then there is left shift operator, there is right shift operator, hello. And so these are few of the operators that we can start to work with. So first of all, let us start with AND operator, that how it works. AND operator, what it does is that whenever you will say that 6 and 7, right? So it starts to work on the bit level. It means what it is going to do is it is going to multiply the uh, subsequent digits or the subsequent bits. For example, let us take an example. So if suppose I'm saying that 7 and 8, right? So what is the binary representation for 7? It is 0, 1, 1, 1. And what is the binary representation for 8? It is 1, 0, 0, 0. Now what you have to do is you have to basically do the AND operation on the bits. So it simply is multiplication of the two bits. So 0 multiply 1 is obviously 0. Then 1 multiplies 0 is 0. Then 1 multiplies 0 is 0. And 1 multiplies 0 is 0. So AND operator internally is doing nothing but multiplying 1 and 0 to each other, right? The subsequent elements. And this is the final result that you're getting, which is 0, 0, 0, 0, which basically represents 0 itself. If you will see that what is the binary representation for 0, then it is 0, 0, 0, 0, and hence you're going to get the final result as 0. Let us try this one. That are we really getting 7 and 8? The final answer is 0. So I'm going to print the result for this one. So print the result for this particular operator, which is 7 and 8, and we should get 0 as the final answer, which is absolutely correct. Now let us go for 5 and 8. So now the binary representation for 5 is 0 1 0 1, right? And now we have to AND it with 8, and 8 stands for 1 0 0 0. So again, when you will multiply the subsequent digits or the binary bits, you're going to get the final answer as 0 only. So let us run it again, and this is what you're getting. So are we clear with that how AND operator works? Are you getting it that how AND operator works? Let us consider one more example. So suppose we are taking 4 and 5, right? So 4 and 5. Now the binary representation for 4 is 0 1 0 0. So 0 1 0 0, and we have to AND it with 5, which is 0 1 0 1. Now you can see that the final result would be 0 and 0, which is 0, then 1 and 1, which is 1, afterwards 0 and 0, which is again 0, and then 0 and 1, which is 0. So 0, 1, 0, 0, which is basically the binary representation of 4. Hence, here we should get the final answer as 4. Now let us see, run it, and this is what you're getting as the final answer, right? So I hope that this is clear to everyone, that how bitwise or bitwise and operator works, right? If you will go for the next operator, which is or operator. So before going for the or operator, just tell me about this, that whether or not this is clear. Everyone, is it clear how bitwise and operator is working? Should I repeat it? How the output is 4? Yeah, again, let me come again with this. So we were doing this operation for 4 and 5. Now the binary representation for 4 was 0, 1, 0, 0, and the binary representation for 5 is 0, 1, 0, 1. So as we have already discussed, that you have to multiply the digits, right? The bits. So when you will multiply 0 and 0, the final output you will get as 0. Then when you will multiply 1 and 1, so let me do one thing, that let us write the final result here itself. So 1 into 1 is 1, then 0 into 0 is 0, and 0 into 1 is 0. The final answer is coming out as 0, 1, 0, 0, which stands for 4. So that's why you're going to get the final result as 4, which you are getting here, of course. So you can see the answer. So this is the final result, which is 4. Right, so this is how we are working. Is it clear now? Everyone, is it clear? It is clear, right? Now the next set of operator that you have to, or the next operator that you have to work on is your OR operator. OR operator basically works as if it is a plus operator. Not exactly a plus operator, but as if it is a plus operator. Now you have to consider this thing, that if you will add 0 plus 0, then you're going to get the final result as 0. If you will add 0 and 1, you will get the final result as 1. If you will add 1 plus 0, you will get the final result as 1 only. And if you will add 1 plus 1, then you will think that you are going to get the result as 2. But because this is just about a bit, and a bit cannot be more than 1, right? It can be either 0 or it can be 1. So that's why we have to store here 1, not 2, right? So only this much you have to understand, that when you are going for OR operator, you have to think of it as if you are adding two numbers. But the only case that you have to distinguish from it is this 1 plus 1 case, wherein your result is going to be 1, not 0, right? So you just have to remember this in case of OR operator. And let us start with it, how it is working. So let us print the value for 7 or 8, right? Or otherwise 7 or 2. So when you will say 7 or 2, now the binary representation of 7 is 0, 1, 1, 1. You can see it over here. And binary representation of 2 is 0, 0, 1, 0. Now it is saying that you have to simply add the two digits. So 0 plus 0 is 0, 1 plus 0 is 1, 1 plus 1 is also 1, because we have just seen that how it works, and 1 plus 0 is 1 again. So 0, 1, 1, 1 is the final answer, and that is nothing but 7 itself. So here we should get the final answer as 7, right? Let us run it and check it out. And yes, we are getting the final answer as 7. Now let us try for 4 and 6. So 4 or 6. So the first number is 4 and or and 6. So 4 is basically represented as 0, 1, 0, 0, and 6 is represented as 0, 1, 1, 0. Now let us check again that how it is working. So we have to add up the two digits. So 0 plus 0 is 0, 1 plus 1 is 1, 0 plus 1 is 1, and 0 plus 0 is 0. So this is the final answer, which is nothing but 6 itself. So here we are going to get the final answer as 6. Let us run it again. And yes, it is 6. So this is how logical OR operator works. I hope that this is again very much clear that how it is working. Are you guys getting this or not? No, no, you don't have to remember these numbers from 0 to 9, right? It is just for the explanation purpose that I'm explaining it in this way. This is just an operator which maybe you people will not use very often. So no need to remember it. Just remember the way it is working. Because whenever you will try to find out, for example, you want to find out that what is the binary representation for 6. So you don't have to remember it. You can use a function which is bin, and then you can give the number, for example, 67, and it will give you the binary representation for 67. So it is 10000011. So you don't have to remember anything, right? If you will go for binary representation for 6, then you can run it and you will get the binary representation, which is 110, right? It just ignore all the leading zeros, and it prints the binary number starting from the first one, right? So you don't have to remember anything. Okay, now this is about the OR operator. If you will talk about XOR operator, so XOR operator works in this way, that it says that if both of the numbers are same, right? If both of the binary digits are same, then you have to give the final output as 0. And if both of the digits are different, then the final result will be 1. So let us start with an example for this particular definition. So suppose the first number is 5, right? So 5 is basically 0101, and we want to XOR this 5 with, suppose, uh, maybe with 8, or maybe with 9, right? So we want to XOR it with 9, and 9 is basically 1001, right? So this time what operation are we performing on these two numbers? So it is XOR. XOR says that whenever the numbers are different, so first one is different, 0 and 0 XOR 1. So whenever they're different, we have to give the final answer as 1, and whenever they're same, then we have to give the final answer as 0. So 0 XOR 1 is 1 because they are different. Then 1 XOR 0 is again 1 because they are also different. Then 0 XOR 0 will be 0 because they are same. And then 1 XOR 1 is also 0 because they are again same. So this is the final answer that we are getting, and it stands for 12. So now let us see that whether or not we are getting 12 as our final answer for 5 XOR 9, right? Let us try. So print 5 XOR 9. So we should get the final answer as 12, and yes, we are getting the same answer. So this is how XOR operator works, right? Let us try one more example for this. So suppose this time we want to say that we want to XOR this value, which is 3, with 0 1 0 0, right? We want to XOR these two values. So this is basically 3, and we want to XOR 3 with, this is 4, right? So we want to XOR these two values. So the final result that we are going to get is 0 XOR 0. As they are same, then we are going to get 0. 0 and 1 as they're different, then 1. 1 and 1 XOR 0 is 1, and 1 XOR 0 is 1. So it stands for 7. So if you will XOR these two values, that are 3 and 4, then you should get the final answer as 7. Let us try this one. So print 3 XOR 4. Let us run it, and this is the final answer, which is 7. So are we clear with this? Yeah, everyone is clear, right? So basically what you have to do is you have to follow this simple rule, which is we have to follow this simple rule, which is that if the numbers are same, if the binary numbers are same, that is 1 XOR 1 or 0 XOR 0, then you have to give the final answer as 0. And if the digits are different, for example, 1 XOR 0 or 0 XOR 1, then the final answer would be 0, right? So if you want to go with this result, for example, if you're saying that 0 XOR 1, then the final answer that you're going to get is 1, of course. But if you will go with this, that 3 XOR 3, then of course you're going to get the final answer as 0, because the same number always gives 0 as your answer. Is it clear how XOR works? Bhanu, is it clear? Alright, so I think that this is clear. Now there are two other operators which are very simple and very interesting, that are left shift and right shift operator, right? How left shift operator works is that it says that if suppose you have a number, for example, if we talk about 1, suppose, right? So 1 is represented in this way. And now I'm saying that 1, we should basically left shift this number by one digit. So this will become, so initially it was 0001, and when you will left shift this number with one unit, then it will become 0010, right? If again you will go for left shift, then it will become 0100. If again you will say that left shift it, then it will become 1000, right? So whenever you're doing a left shift, it always is multiplying the number by 2, if you will see it. So this is 1, this is binary representation for 2, this is binary representation for 4, and this is binary representation for 8. It means that when you are left shifting a number by one unit, you are actually multiplying it with 2, right? Let us see this in the working example. So suppose if I'm having 1 as my number, and I'm saying that left shift this one by one digit, and we will run it. So it will multiply it by 2. If you will go for two digits, we are saying that left shift it by 2 units. So basically you are doubling the double, right? So now it will become 1 into 2 into 2. That will be 4, right? If you will say that left shift this number by 3 units, so it will become even the double of 4, that is 8. So if you are taking, instead of 1, if you are taking 4 here, and you are saying that left shift it by 1 unit, so it will just double it once, so it will become 8. But if you are saying that left shift it by 2 units, then it will double it twice, right? So 4 will become 8, and then 8 will become 16. So this is how it works. Left shift will basically always multiply the numbers uh, by 2 as many times you want, right? So it totally depends on that, what how many digits you are shifting towards left. Based on that value, it is going to left shift your number. Is it clear? Is left shift clear? All right, if it is clear, then please answer me this, that answer me that what will be the answer for 89 left shift 4. Please write down the answer. Exactly. So everyone is getting the answer, right? It is basically that 89 will be doubled first, afterwards it will be doubled again, and it will be doubled again and again. Right? So it will be doubled four times, right? So 89 will be first of all doubled. The answer would be something. So let us see that what will be the answer. So when it will be doubled for the first time, right? So print 89 and then left shift by 1. So 1 simply means that double it once, right? That is 178. Now 2 times means that 178 also will be doubled. So the answer would be 356. 3 times means that 356 will also be doubled. So this will become 712, and 4 times means that 712 will also be doubled. So this is how it is working. The left shift operator basically doubles every time, right? And in the same way, if you'll talk about right shift, so right shift operator always, divide the number by 2, right? If it is even number, and if it is odd number, then subtract the number by 1, and I mean just take the floor division. So let us see that how right shift operator works. So suppose 5 is the number, or suppose 8 is the number, and we are saying right shifted by 1. So it is going to be divided by 2, right? So let us see. So let us run it, and 4 is the answer. If you are dividing the number 8 by 2, then 4 is the final output. If you will divide it or shift it by 2 digits, then final output would be 2. That is, 4 will also be divided by 2. If suppose instead of 8 we have got 64, then 64 first of all will be divided into half, that is divided by 2, that is 16, sorry, 32, and then 32 will also be divided by 2, that will give the answer as 16, right? That is divide by 2 for 2 times. So this is how right shift operator works. Is this also clear, everyone? Are we clear till this point that how left shift, how right shift operator is working for us? Now, if there is any sort of doubt, please ask me the question. We will continue with conditional statements in tomorrow's session, right? And we have to clear it with few of the examples also. We have to consider a few examples. And yeah, tomorrow the session is going to be very interesting because then we will also consider match a statement, how it works. So you're going to enjoy it. So you have to be very much regular in the classes. I'm expecting that all the people that have joined today are going to meet me in tomorrow's session at 9 as well, right? So this is it. I hope that this is going to be useful for you people, and let's catch up tomorrow. Bye bye, guys. Take care, everyone.